Okay, guys, I've been waiting for this one. Let's talk about alcohols. Obviously, I'm going to be talking about alcohols in a chemistry sense. Alcohol is what we actually call ethanol in the science lab, and I want that to be really clear. Alcohols are a group of compounds. We're not just talking about the alcohol we get in like beer and wine and stuff. There is a whole range of chemicals called alcohols, and we'll look at how to identify those as we go through on here. We're going to break this down to two parts. The first part is going to be very much about how you make an alcohol and what that kind of looks like. And the latter part is going to be very much around the reactions, chemical reactions that alcohols do, and so we know what's going on with those. So here we go. Alcohol has been made exactly the same way for thousands of years. There are ancient societies that we've found evidence that they've been, making their own alcohol. So it's amazing that it's been around for so long. We don't actually even, it's been so long since they did, we don't even know who invented it. Like, it's before people were writing things down. That's amazing that we've been making this chemical for so long. The alcohol that we have in alcoholic drinks is an organic molecule. That means it contains carbon, and that's called ethanol. And ethanol has the formula CH3CH2OH. That's 2 carbons, 6 hydrogens, 1 oxygen. And it forms part of this homologous series. Just like we had a homologous series for alkanes and alkenes, now we have a third homologous series we're going to be looking at called the alcohols. Right. To make an alcohol, firstly what you need is a source of starch or sugar. This is normally some kind of grain that is grown, and traditionally different alcohols are made from different things. So in places where there were lots of grapes, they made wine. Here in the United Kingdom we had a lot of barley, so we made beer and whiskey. Sugarcane grows naturally in the Caribbean, so they make a lot of rum. Wheat grows quite readily in like Russia, so they make a lot of vodka. The different grain you start with is what the alcohol ends up becoming. I'm going to concentrate on making whiskey and beer. The first thing you need to do is sort of malt your grains. So we're going to heat it and turn it in water, and it will start to germinate. You can see that in the middle picture there. The seeds start to germinate and start to grow a little bit. And that creates lots of sugar. And that sugar goes into the water, and it makes a solution that we call wort. And it's stirred in these vats here. The next step that we do, yeast is going to be added to these vats. And those will start doing anaerobic respiration. And it will make alcohol. If we're going to make beer, this is where the process ends. So we just finish this reaction and bottle it up and keep those bubbles of CO2 in it, and that will turn into your beer. But you can only make an alcoholic drink up to about 10% alcohol this way. And that's because the yeasts will actually die once they get to a certain ethanol concentration. If you want to go above that concentration, then we need to use a different process to turn our beer into a whiskey, for instance. So the equation for fermentation is this. We've got C6H12O6, it's our glucose molecule. It's going to make 2 moles of carbon dioxide and 2 moles of ethanol. So if we want to turn the beer into whiskey, we need to do a fractional distillation. Now in the lab, you've probably seen this, we did this in year 9, but here it looks a little bit different. These are humongous copper containers, and actually the vapor travels down the arm that you can see there, where I've highlighted it, and it condenses in the outside, where it's much colder than indoors, and then it gets redistilled and redistilled. So this will pass from one still into the next still into the next still. Ethanol obviously has a lower boiling point with water. So when you do this fractional distillation, each time you distill it, you're going to get less and less water in there because more ethanol will come off. It's actually very difficult to get 100% pure this way because we're not being as controlled as we would normally do with a proper fractional distillation that we were doing in the lab. This is done on a more general process. They heat it for a certain length of time, they expect most of the ethanol to go through, etc., etc. The more times we distill, the higher the alcohol content gets. So you can see here that we've got about 20%. This is from the first distillation. On the second distillation, it goes up to about 55%. And on the third distillation, it can go up to about 80%. So that's very, very alcoholic indeed. At the bottom of the still, what's left over, you get stuff like this. This is all the oils and like nastiness and like those solid bits of wort and all of that stuff that won't vaporize and won't go up into the vapor and then condense again. So we end up with this kind of stuff right at the bottom of the still. We don't want this though, we want to collect the liquor, obviously. Whiskey is then aged in barrels. They need to be there for at least 5 years, sometimes more. And this will give it its flavour and its colour. And then obviously at the end you'll end up with a finished product that you may wish to enjoy. Alright, let's have a look at the reactions of alcohols then. Most alcohols from the laboratory are going to be made in a different way because we need them to be 100% pure. We can't be dealing with having all these other things that are in there in the say that we would for an alcoholic drink. So instead what we do is we take ethene and we react it with steam, and we use a catalyst. We use a phosphoric acid catalyst. And the chemical reaction for this is written here. This is an addition reaction, and the water adds to the CC double bond in ethene. So a H will add to one side, and the OH will add to the other one, using the phosphoric acid as a catalyst for the reaction. Like I said previously, ethanol is part of a homologous series of alcohols. An alcohol has a general formula, just like all of our other things did. And the formula for this is CnH2n plus 1 OH. So ethanol is C2, so that's H5OH. Propanol is C3, so that's H7OH. Butanol is C4, so that's H9OH. Remember, you're doubling it, add 1 OH. We're using the same naming system, methan, ethan, propan, butan, but instead of ane, we're now adding ol to the end. So it's methanol, ethanol, propanol, butanol, pentanol, hexanol, just the same as the process that we said before. Now let's talk about these properties. All alcohols are flammable, which means they do combustion, and just like all things that combust, they're going to make carbon dioxide and they're going to make water. They can also be oxidized. Now, we won't really go into this right now, but when we study carboxylic acids next year, or actually probably next week to be honest, because we are whizzing through, then when these are oxidized, then they'll form an acid. This is actually how we turn alcohols into something like vinegar. If you think of a white wine vinegar or a red wine vinegar, they actually take the alcohol and oxidize it into an acid. So the wine vinegar becomes, the wine alcohol is oxidized into an acid. Also, they all react with sodium. If they react with sodium, they form a sodium alkoxide, and it also make hydrogen gas. This is very, very similar to the reaction of sodium and water. It's just that the OH from the alcohol is acting like the H2O from the water, so a very similar reaction. Right, let's look at these two reactions then. Here's the combustion reaction. Ethanol and oxygen make carbon dioxide and water. So here's our balanced chemical equation. C2H5OH plus 3 oxygens makes 2 moles of carbon dioxide and 3 moles of water. With sodium, again, we've got C2H5OH, and we're going to have sodium there, 2 moles of each. Sodium ethoxide you can see here. Now the C2H5O minus ion is the ethoxide ion. It's lost the hydrogen to form hydrogen gas, and so we end up with this ethoxide ion. Now, if you started with propanol, you'd have propoxide. If you started with methanol, you'd have methoxide. So make sure you're changing the name of your alkoxide ion when you're doing these chemical reactions. You can see here that the reaction with sodium in different alcohols has a pattern. So methanol is way faster than ethanol, which is way faster than propanol. The shorter the chain of the molecule is, the faster the chemical reaction will be. All right. Thank you very much, guys. Have a good day.